Okay, let's put this all together. Tara dives off a 4-meter diving board. Her height, h in meters above the surface of the water, is defined by the relation h equals negative d squared plus 3d plus 4, where d is our horizontal distance in meters from the end of the board. Find Tara's horizontal distance from the board when she enters the water. So what is it asking? If we think about this as a sketch, here's the board. Here's Tara, she's going to dive. Her path follows a parabola and she hits the water. So over there, that's where she's going to enter the water. This isn't back in time, this is where she was, just the path. She bounces off, reaches a peak, and comes down. We also have the y-intercept. Now the y-intercept, I recognize and I notice, is 4. So that point right there is 0, 4. I know that. If I need to know when she enters the water, I'm looking for the x-intercept, and I'm looking for the positive one, because she's jumping forward. She's not bouncing back towards the deck. Remember, this isn't the real part of the dive, this is just the curve that follows the path of the dive. So I need to factor that equation. Now, it's almost like a simple trinomial, except it's a negative. So the first thing I'm going to do is I'm going to factor out negative 1 from that whole thing. And now I've made it a simple trinomial. Simple trinomial, I need two numbers that multiply negative 4 and add to negative 3. Those numbers are going to be negative 4 and positive 1. Once again, I now have factored form. Negative a value means it opens down. That makes sense. We jump up and then gravity takes over and we come down. And then from these, I set the first one equal to 0, we got d equals 4. Set the second one equal to 0, d equals 1, and those are my x-intercepts. So I know that this is 4, 0, and this is, sorry, that should be positive 1. I said positive 1, but I wrote negative. And that should be negative 1. So now, what is her horizontal distance? She hits the water 4 meters away from the edge of the board, right? So it's 4 meters from the edge of the board. If I now continue with that, I need to find her maximum height. Because this opens down, it has a maximum, and the maximum occurs at the vertex. So to find the vertex, I'm going to add both x-intercepts, divide by 2 to find my axis of symmetry. So max height, I need the vertex. So I'm going to find the vertex. To do that, first I need my axis of symmetry. I'm going to add negative 1 plus 4 and divide it by 2. Negative 1 plus 4 is 3. 3 divided by 2 is 3 halves. And because I'm talking about meters, I can change 3 halves into a decimal, 1.5. There's my axis of symmetry. I know that point is 1.5. I just don't know what the height is. Now that I know what my x, or in this case, my d value, she reaches her maximum height when she is 1.5 meters away from the board. I'm going to sub that into factored form or standard form and solve. So height equals negative 1, and I have d minus 4, so 1.5 minus 4, or 1.5 plus 1. You can sub it into factored form again or standard form. 2.5 times 2.5 times, well, negative, times negative 1 is 6.25. So again, that is my y value of the vertex, and that is her maximum height. So she starts from 4 meters high, bounces, gets a height of 6.25, and then comes back down to the water. Because this is water, she would sink underneath a little bit, and that's where the curve would end, the real part of the curve, and then buoyancy should float back to the top. All right, let's try a second example together. Ball is thrown upward with an initial velocity of 8.4 meters per second from a height of 1.5 meters off the ground. Okay. There's our y-intercept. The rest of this just relates to the equation, so I'm still looking at the equation. The height of the ball in meters above the ground after t seconds is modeled by the equation h equals negative 4.9 t squared plus 8.4 t plus 1.5. Determine the height of the ball after 5 seconds. So right now, we're looking at when the time is 5 seconds, or 0.5 seconds, what's the height of the ball? So we're going to sub that in to our equation and solve. 0.5 squared .4 times 0.5 I have addition and multiplication, or I only have addition and subtraction left, so I can add all my terms. So after 0.5 seconds, the ball is 4.475 meters high, off the ground, whatever. So that is our point, 0.5 and 4.475. We have a y-intercept of 1.5. We don't know our x-intercepts, we don't know our vertex. After how many seconds does the ball land on the ground? So we want to know at what time. What is our x-intercept? So that's how long it's in the air. Our x-intercept is when it lands in the ground. If we look at our equation, these are decimals, there's a negative. I can try and use my magic numbers. I can try and common factor this out. If I common factor this out, 8.4 divided by negative 4.9 does not give me a nice number. 1.5 divided by negative 4.9 does not give me a nice number. So at this point, I'm going to go right to the quadratic equation. Remember that x equals negative b plus or minus b squared minus 4ac all square rooted over 2a. So using my a, b, and c values there, instead of x, I'm looking for time. So I might write x, I might write time just to remind myself that that's what I'm looking for. So, negative 8.4 plus or minus 8.4 squared minus 4 times a, negative 4.9, times c. All of that is square rooted, and I need all of that answer divided by 2 times negative 4.9. So now, let's do the math. 8.4 squared. Negative 4 times negative 4.9 times 1.5 gives us 29.4, and it's positive. It's either minus a negative number, minus a negative is positive. All that square rooted, all times negative, or all divided by negative 9.8. If I split that into two, the positive side and the negative side, and I have negative 8.4 plus the square root of 99.96 all over negative 9.8. My other solution, negative 8.4 minus the square root of 99.96 all divided by negative 9.8. Now the question asks for 1/10 of a meter. That's 1 decimal place. You notice I had 2. I have 1. I'm not rounding to the end of the question. And I don't like this. I'm going to say 2 decimal places. Type this all into my calculator. Negative 8.4 plus square root of 99.96 all divided by negative 9.8. Negative 0.16. So again, that's one of my x-intercepts. I don't care about that one. I only care about this one for answering this question. Negative 8.4 minus the square root of 99.96 all divided by negative 9.8. Rounded gives me 1.88. So the ball is thrown upwards, reaches its maximum height, starts coming down, and hits the ground after 1.88 seconds. So how many seconds does the ball land on the ground? Therefore, the ball hits the ground after 1.88 seconds. Again, if I want to know the maximum height, I'm looking for the vertex. To find that, I'm going to find my axis of symmetry. Round to the nearest meter, it's going to be at the end. So right now, I want to know the time when the ball is at its peak. So after this many seconds, the ball is at its peak. So I'm going to add my 2 x-intercepts together. Divided by 2, and I get time of 0.86 seconds. It takes 0.86 seconds for the ball to get all the way to the top, and then it's going to start coming down. I'm going to take that, and I'm going to sub it into either factored form. I don't have factored form, so let's sub it into standard form, the equation given. Zero 0.86 squared, keeping all the decimals till the end. 8.4 times 0.86, all plus 1.5. Do my next multiplication step. Negative 4.9 times 0.7396. Add them all together. Now I'm going to round to the nearest meter. So therefore the ball goes or reaches the maximum of 5 meters in the air. And I've used my factoring quadratic formula and solving quadratics to answer a real life question.